Yeah.
Good afternoon, everyone. It looks like we still have a few folks trickling in, but I just want to be respectful of our time together since we only have an hour. Welcome to the second installment of our AI Plus Education collaboration. I'm Suzanne Rosenblith. I'm the Dean of the Graduate School of Education here at UB. In a minute, we're going to turn this over to Ranga, who's going to be facilitating today's discussion. But in a moment, Carly is going to put a survey in the chat, and looks like she already did. So the reason for this survey is, and maybe some of you have, excuse me? Oh, someone might have been on, maybe make sure you're on mute. There have been a number of occasions, and maybe some of you have had this experience where I've had this experience where folks in K-12 have said to me, folks who are in leadership positions in K-12 have said to me, well, I'm just not going to do AI. And although I come from the humanities and social science side of education, I know enough to know that I don't think that that's actually a reality. And more so, as the more I learn about AI and education, the more I understand the profound opportunities for addressing inequality in our schools and for supporting student learning in ways that we just may not be able to do without its assistance. So that got a few of us in the Graduate School of Education thinking that perhaps a service that we could provide is to collaboratively put together some kind of a primer, like what is AI? What is it not? Maybe what we're thinking is some people can't even see in their mind's eye what it is we're even talking about. And so the survey that we're providing to all of you should help us think about what might go into this primer that could be of assistance to K-12 personnel, but especially leaders that make profound decisions for their schools and their districts. So I'm going to leave it at that. You can put your questions, and I think there's open-ended spots on the survey, so you can add whatever you want in, and we will certainly be back in touch. But now I'll turn it over to Ranga. Thank you for your time.
Thanks, Suzanne. Let me just share my screen. Hi, so good afternoon, everyone. I'm Ranga Setlur. I'm the co-director of UB Center for Unified Biometrics and Sensors. We work on applying AI to many different areas. I'm also the managing director of the new NSF National AI Center for Exceptional Education and AI Institute for Exceptional Education. So today my talk is going to be about leveraging machine learning for personalized education, special needs education. And that's sort of the prime reason for our institute. And therefore, I'll be focusing on what we plan to do with our institute and essentially how we see AI helping us in special needs education. Please feel free to sort of post your questions in the chat, and I'll try to answer as many as I can at the end of the talk. So this National AI Institute Yeah. So this National AI Institute for Exceptional Education is funded by the National Science Foundation and the Institute of Education Sciences of the Department of Education. And at this point, since this is a National AI Institute, and Suzanne sort of mentioned that AI is in education, especially, is sometimes controversial. I think this is a good time for us to have this first poll. And I'd like to see if any of you change your minds by the end of my talk. So, and the question is, how do you feel about the use of AI for special education? And it's just a 5-point scale here. And we'll see if the needle moves in any way at the end of the talk. So we'll end the poll in 30 seconds. And it seems like there aren't too many people in this audience that are concerned about it. I think people should be always concerned about the use of technology in any field. But we are also very excited about using AI in this field. And I'm glad that in this audience, most of the people are excited, intrigued, or are neutral. And there are very few people that are concerned, and no one that's very concerned. But let me sort of, yeah, looks like my controls. Yeah. So this particular institute is led by the university at Buffalo. We have 8 other faculty from 8 other universities as partners across the length and breadth of the country. My colleague Jinjun sort of alluded to some of this in his talk last month, but this is just a refresher. The National AI Institute's program is a flagship program of the National Science Foundation that has been set up to establish these National AI Institutes in a variety of different topics where the US wants to ensure that they stay competitive in the artificial intelligence field. And of those 25 institutes that have been set up so far, each at a funding level of about 20 million over 5 years, with the chance to sort of get another 20 million for another 5 years. So it's a huge investment that the United States government is making in AI technologies. These institutes are expected to be the nexus points for any conversation in these areas. So there are 5 education-related institutes. Ours is aimed towards developing AI technologies for learners with disabilities. There are, however, other AI institutes that are focusing on other things. AI ALO focuses on adult learning and online education. Engage AI talks about engaged learning. ISAT is an institute for student AI teaming. And the last institute is Invite, which is for inclusive and intelligent technologies for education. So there are 5 institutes. We were the 3rd in the series. The last 2 were awarded just recently. So we've been in existence for a year now. This is sort of where all of our faculty come from. We have 13 faculty from the University at Buffalo and 17 other faculty spread across the country. And we have a very good representation. We have 13 female faculty members, 17 male. We have underrepresented minority individuals, people with a lot of awards and honors. And we hope to use all of our collective expertise to ensure that we can develop good solutions for this social good cause. And this is just the leadership as the PI is Venu Govindaraju, who's the Vice President of Research at UB. My colleague Jinjun gave the last talk. He's the Scientific Director of the Institute. I'm the Managing Director. We have a bunch of folks from UB that are in charge of the broader impact initiatives as part of this institute. As I said, it's meant to be a nexus point. We have an advisory board from across all stakeholder populations. We have Brian Graham, who's the superintendent of the Grand Island School District. We have the Multicultural Affairs Secretary from the ASHA, the Speech and Hearing Association, Megan Brett Hamilton. We have Anil Jain of MSU, who's a leader in AI technology. We have people from industry, from Tomato AI. We have school-based SLPs. We have people from foundation, and we have other multidisciplinary leaders from across the partner universities. So why did we choose speech and language related disorders as the focus for our National AI Institute? The reason was that about half of the children, more than half of the students that get services under IDEA, which is about 3.4 million children, have speech and language related disorders. So it was our idea that if we sort of address these are sort of cross-cutting and foundational, and the impact of the institute would be more impressive. So the other aspect of this is that the people who provide these services, there is a severe shortage of the expertise that is required to provide these services to these students. As per Bureau of Labor Statistics, there are only about 61,000 SLPs at US schools as of 2021 to service 3.4 million children that are in need of these services. So clearly, there is a significant need for some help here to make sure that services are adequately provided, and that's the challenge. So how do you sort of, can AI be used to provide, to help in providing, scaling the ability of SLPs to provide evidence-based services? Again, there are a number of questions that are being addressed by the university, and I'll go through a few of them. So Jinjun alluded to this briefly in his talk as well. Currently, the way children are identified as having speech and language challenges are by either parents noticing them or teachers noticing them in daycares and then referring them for further evaluation. In this process, the evaluation is still done by SLPs, and they determine the eligibility for IEPs for children in the school system, and then the SLPs provide group-based multi-target intervention. In this scheme of ad hoc referral, children in need may be missed or identified late, and so that is sort of suboptimal in getting the services that the children need. And this is sort of borne out by the experts that sort of tell us that typically it's important to provide intervention between birth and 5 years for children with language development needs. And because of the ad hoc nature of how screening is done, many children are missed or referred too late. Also, as I said, the ad hoc, the screening is done typically by parents, and many parents are not aware of the early warning signs of speech language disorders. And again, that's part of the reason why many students are missed. Also, the other argument is that there will be the people in the healthcare realm, the healthcare providers would be able to identify these children and provide them with the need for further evaluation, but nearly 20 million children lack access to pediatric care, and this is even worse in rural areas, and therefore it's possible that healthcare providers will not be able to identify the children. So given all these reasons, there's clearly, like, two vicious cycles at work. There is a shortage of SLPs, as can be seen by the statistics, so leading to ad hoc referral where universal screening is not possible, leading to late or missed identification, which requires more SLPs, and that exacerbates the problem. On the intervention side, because of the shortage of SLPs, group-based intervention is the only way intervention can be provided. It's not to say that group-based intervention is bad. There are some situations where group-based intervention is still the optimal way of providing the intervention, but individualized intervention is certainly not possible. And that could lead to poor academic performance, which could only be so you would need more SLPs to alleviate this problem, and we have shortage of SLPs. So these two vicious cycles exist in the system today. So what do we plan to do as part of the AI Institute? We, on the screening side, we want to use AI to help screen children in a more universal way. And we want to target this to the daycare system, which is 3 to 5. The technologies that we develop could be used in homes as well, even at earlier ages. But we wanted to focus our research in the daycare setting, where it's a public setting, where some of the privacy concerns are alleviated. If you sort of develop better screening techniques using AI, you'll be bringing more children, the children that were currently missed, into the system that need services. So which means you're exacerbating the problem some more on the intervention side. So it's not enough to just focus on screening. On the intervention side, there are a lot of intervention apps. AI has been used in certain ways, but not in a systematic way. And so what we seek to do is build something that we call the AI orchestrator, which synthesizes, which has a knowledge of all of the interventions that exist and when they are applicable, knows what the evidence-based practices should be, and is able to recommend to the SLPs what intervention is appropriate for a particular child. So all of this information, we do want to keep. SLPs are not going to be put out of a job right now, because we don't even anticipate the AI to be able to replace them anytime soon at all, if at all. And so currently all we are trying to do is provide tools that would facilitate SLPs to scale their services, and they would still be at the center of this picture, where they will be doing the eligibility determination, and they will also be helping in administering the interventions. Where does AI help? AI will provide them with information that they can use for doing this effectively, and also in being able to do this in an individualized fashion, which currently cannot be done. So here is an example of one particular screening test that exists. This is the sentence diversity priming task that's been developed by our colleagues at the University of Illinois, Urbana-Champaign. And in this test, image is presented where you have a subject and a verb. So the SLP prompts the child with a single picture and says and describes the picture. The baby is sleeping, where you have a subject and a verb, and then a different picture is presented to the child, and the child is supposed to respond in a similar fashion. And so if a child has speech and learning challenges, either the child may not respond at all, or might just say the subject, or respond in other ways. So if the child says kitty, there's a prompt that says what is happening here, and the child says kitty is sleeping. Perhaps says kitty is sleeping if the child doesn't say that. So there are some metrics, and those metrics are calculated, and that's how children are screened using this particular test. So now AI can be used to just sort of do this without the presence of the SLP, collect all of these, be able to prompt the child, be able to recognize the child's speech, be able to recognize what the child is doing, capture all of the characteristics, and present all of that to the SLP to then deal with it as they see fit. So that's one way of a single screening test where AI can actually be used to instantiate AI version of the test. And that's just the bare minimum, that's scratching the surface. Ultimately, the goal is this AI will be some embodiment that could just be sensors in the environment that are observing the children in their natural interactions in the wild with their peers or their teachers or SLPs. And it's able to capture all of this. It's able to detect who's saying what, separate out the speech signals, be able to, not just the speech, multimodal signals, and then be able to capture all of this information and present this to the detect what are potentially snippets that are of interest, that would be of interest for an SLP to look at for screening or for intervention purposes or for progress monitoring purposes. And that's essentially how we see eventually the AI screener operating. So what are the signals of interest that AI would need to detect here? This is just a small subsample of the kind of signals that AI is capable of capturing and would be valuable for doing what we are setting out to do. Things like being able to transcribe speech. Getting the orthographic transcription, the phonetic transcription, any disfluencies in speech such as repetitions, mispronunciations, the prosodic nature of the speech, like where is the emphasis, where is the change in pitch, etc., which could be factors that are indicative of things. Then there are other nonverbal things like gestures. There are also things that are face sometimes leaks out, such as emotions. So the AI screener and later the orchestrator will use these same things for progress monitoring. Is it'll the individual modules that AI has will do each of these things and then bring them all together in a more so there will be higher level modules that use this information to then produce metrics that are higher level that can then be analyzed by the speech language pathologist to make determinations. So on the intervention side, there are multiple targets, as you all very well know. For the interventions, again, the evidence-based intervention methods, just given how busy SLPs are, it's hard to keep track of literature. Stimulus materials for doing a particular intervention to address a particular target. There are a plethora of choices. I was at the ASHA convention and we had a booth there and we saw like how many vendors there were that were supplying all these materials. Again, for one particular target need, you can have over like 200 different product stimulus materials. Then there are elicitation techniques, what sort of scaffolding is based on what scaffolding is needed, based on the abilities of the child, the suitability of the context, you might need to choose this. So this is sort of a combinatorially explosive set of choices, and it's hard for SLPs to make evidence-based decisions because of this scenario. So what does the orchestrator do? So the orchestrator, as I said, can analyze this collected multimodal data. It can map the child's learning targets and challenges by like this progress monitoring, this calculating the relevant metrics. Then it'll have this knowledge base of these interventions. It can, based on some AI techniques, recommend these individualized intervention plans, sort of akin to movies being recommended by Netflix. Obviously, this is not even as this is nowhere near as simple as that. It's a very complex thing, but AI has the capability of doing that and also to test out these novel intervention methods. And we also will have both AI-driven screening tests as well as AI-driven intervention solutions, novel AI intervention solutions that we plan to do as part of this, develop as part of this institute. So what is involved in this orchestration task? Essentially, you need this knowledge base. So we have like experts in natural language processing, experts in knowledge graph development that are trying to pour through literature that's available, then sort of tag them appropriately, create these knowledge graphs, which would be one of the inputs into our recommender systems. These recommender systems themselves can use a variety of AI techniques based on reinforcement learning or large language models or a combination of both. You need to know the current status of the child in terms of all these metrics. So you need this multimodal perception for progress monitoring. With these inputs, the recommender system can recommend certain interventions. Those interventions can be administered through various embodiments. And these embodiments include dashboards or intervention apps, or it could be socially assistive robots, or it could be conversational agents like Alexa. So these would be our AI embodiments. And there are also new intervention methods and tools that could be developed that we intend to develop as part of this institute. These are things like reader-targeted language transformation and tools for authoring intervention content. So this is sort of a picture of what orchestration means. This is just, again, summarizing what I just said. Essentially, we have the AI screener, which sort of is a bunch of video streams, audio streams, maybe some handwriting, some writing material. You calculate these conventional speech and language measures, calculate novel automaticity measures, and I'll briefly talk about that. Extract snippets of critical moments, generate reports with a dashboard, and with the permission of parents or teachers, the SLPs review these reports. We will validate the usefulness of this, and then we'll be developing a bunch of technologies to help do this. We will have user interface acceptance tests, and then also some validation tests in early childhood classrooms in the 3 to 5 years group. Similarly, on the orchestration side, you'll need all of the techniques that we develop on the screening side, plus more. And so here you have apps. There are new apps that we will develop. There is this reinforcement learning, multi-agent reinforcement learning engine that will sort of try to build this recommendation engine. And again, the target audience here is the grade school classrooms 5 to 10 years. So screening 3 to 5, the interventions 5 to 10. That's how we've sort of formulated the goals of our institute. So here are some of the technical tasks that are required here. So on the bottom, you have some core AI technologies that need to improve beyond where they are currently, because with children's data, the data is scarce, it's noisy, it's challenging to collect. So we need some self-supervised, robust learning techniques where we can use the limited data that we have, but still build effective AI tools. On the recommendation engine side, we use multi-agent reinforcement learning. I'll not delve too much into these because that becomes very technical. So the next layer is a little more, the lay audience can also appreciate the next layer, which is tools for a number of multimodal perception needs that we want to develop. One is like processing speech, of course. Speech and language is the key aim of our institute. So we need speech recognition, we need video recognition, video processing ability to look at various nonverbal and verbal nonverbal behaviors. There's also text recognition and written material. So all of this are addressed in this layer. Then all of the tools that we want to develop, we want to ensure that these are we're not developing technologies that will never see the light of day or will never be used in the settings where it's meant to be used. So human-centered AI design is a fundamentally important for us. So co-design, working with speech-language pathologists, with educators, with students, with student representatives, with policymakers. So we want to bring everybody into the picture and then decide how to design the AI. So that's a core tenet of our institute. So there's the human-centered AI design, and then the embodiments that will be used to sort of administer, to take the AI technologies to the end user. Those should be socially, clinically appropriate. And that's another very important focus of our institute. And lastly, the learnings, and lastly and most importantly is the learning science folks. They will be driving most of this development of the technology. And then when the technology is developed and used and there are these novel technologies, it can also enhance learning science with new insights that are possible because of these AI technologies. The schools and childcare centers will be the validation, testing ground, proving ground for the technologies that we develop. So this is in a nutshell the technical portion of the institute. So I'll just briefly go through some of those things. I'll leave the bottom layer out, which is the core AI technologies. Spoken language understanding, why are we addressing this? You've all used Alexa, Siri in your daily lives these days. Conversational agents are ubiquitous. So, but with children's speech, it's really bad. And I'll show you, I'll just go to the next slide. So age 0 and 3, there's no data on how these technologies work. Age 3 to 5, it's like 55% word error rate, which makes it practically unusable. Age 5 to 10, at 16% word error rate. That's still very high. With adults, it's about 2% word error rate where you can use it. And if you have done a class on Panopto or seen Zoom's transcripts, you know how bad ASR results are even with adults sometimes. So essentially, the spoken language understanding with respect to children, that's a core technology component. That module needs to improve for any of the downstream technologies to work. So that's why ASR is a big focus. Again, a number of, with respect to speech, the conversational agents that you typically encounter, your Alexas and Siris, are trying to understand what your intent is and actually correct any errors you might make, because they want to give you satisfaction and fulfill your need. In our case, we are trying to detect speech and language errors, and which means it's not just recognizing the speech that is being produced, but recognizing the errors that are being made as well, like speech stalls or repetition or abandoned words or any revisions that are being made, calculating metrics such as what is the percentage of intelligible words. So these are technologies that don't exist because that's not satisfying the consumer need. And this is the need, that's the social good need that is currently unmet. And we're building the AI technologies to address that. Multimodality, again, there are a lot of things that processing videos of interactions between SLPs and children can facilitate the SLPs going back, building tools where the SLPs can go back and query these videos and say, hey, like, I mean, is there some problematic behavior that's that you can notice in this particular video, and the computer vision technologies can process this and do this. Not that it's a solved problem, but here's an example of video.
It might happen to get a story going. What would make you run?
A bear.
A bear. So let's say you guys are going to you're going to go home and tell your mom a story about what happened today in school. And let's say you say, well, first this big guy came and got us out of class to learn how to tell stories, and we.
So as you can notice from here, like, I mean, there are things that we want to notice. What is the child doing? Which child is speaking? How is the child reacting? There are nonverbal gestures that happen. So all of this computer vision technologies can detect objects very well, can detect actions these days. But then again, what level of granularity do you want that at? Like, I mean, the object recognition can recognize things at a granularity that is not what is needed for this particular application. It could again be very coarse or it could be very fine, and you want to strike the right balance. Then there are the vision language models that exist now. These are ChatGPT and text, other engines built on top of that can do answer queries such as how many people are in this video, like how many girls are there, how are they behaving. Some questions they probably cannot answer very well now. So current models, so the first thing that we did was take a few videos, just evaluate current technologies, and things like hallucination that LLMs are very capable of, problems with segmenting, things at the right granularity. All of these can cause problems. And so there is a lot of work to be done to actually improve these technologies to the level where you can use it for applications such as the one that I just mentioned, which is SLPs conversing, asking questions of this AI engine and trying to find pieces of a video where things are happening. This same technology can be used real time in observing certain things and recording certain behaviors as well. So lots of interesting applications that you can think of with this. The human-centered AI design I mentioned. So you need those technologies to be cognizant of cultural backgrounds. They should be socially, clinically appropriate. They should be equitable. There should be no unintended consequences. The ethical framework has to be well established so that right at the outset, so that we aren't caught off guard. We need to design suitable form factors for embodiments. The technology has to be at an acceptable accuracy before it's actually deployed in the field. You have to understand various stakeholders' perspectives. Again, the settings where this technology is being deployed. So as you can see, the human-centered AI design is very, very critical. Similarly, with the embodiment, as I've described, like it could be a dashboard form, it could be an intervention app, it could be socially assistive robots. Each of these embodiments is not applicable in every situation. You need to choose the correct settings for the right, and you need to take in human factors and the sensor and networking needs of various school districts, what technologies can they afford, and also human robot interactions, things such as safety, etc. Lastly, the speech language learning science. So some of the things that we are looking at is many of the speech language pathologists that we work with tell us, educators also tell us, that there is this notion of automaticity that they implicitly consider in their heads when they're sort of observing a child. So is that, can AI help in providing some kind of a measurable metric for this, and is automaticity a better metric for assessing the child's language capabilities? And are poor academic outcomes a consequence of the language difficulties or other underlying deficits? So these are the kinds of questions that we also want to answer as part of our institute. And finally, the validation and evaluation. We will need to do rigorous validation using business as usual control interventions and AI orchestrator assisted interventions, and similarly on the screening side. And we're not there yet. We're very far from actually doing validation in schools, but we need to keep that in mind as we work on the things within the institute. So from those vicious cycles, we want to have this virtuous cycle where we're learning from learning current knowledge in learning science. We will advance AI technologies to help us address these problems, adopt a human-centered AI design principle, implement these screener and orchestrator solutions, and then deploy them and assess their, validate them and assess their impact. And all of this, hopefully doing this, rinsing and repeating this, we will be able to provide improved academic impact for children with speech and language challenges. Now, I'm going to quickly do a quick poll. Let's just leave it up for maybe 30 seconds because I know that I've used up a lot of my time. I want to talk about the solutions as well. Carly, do you want to run the poll?
Oh, sorry about that. I'm having a problem launching it. There we go.
So this one was, you just heard me talk about all these areas of therapy. Which area do you believe could benefit most from AI? You can choose more than one if you want. Most probably was the wrong form to use there, but. And we will sort of review this later as well and use that as input for us to see what all of you think about it. So, and as this poll is ongoing, that reducing SLP workloads, I didn't talk about that. And so one of the things with SLP's daily workload is they do a lot of paperwork, and automation, AI-based automation is one of those things that could sort of alleviate that big chunk of their time and provide things like helping them record SOAP notes, automatically generate SOAP notes automatically, etc. So I think we can end the poll. And yeah, if we can stop sharing that, I'll get rid of that. And so let me just go over to example AI applications, and then hopefully, I'll have some time to get your thoughts on those applications. So I'll talk about a few. One, is something that we are working in. The first two are things that we are working in our lab. The last one is something that one of our colleagues from a partner institution is working on. So the screening and intervention using handwriting analysis, we've had a long history of working for building systems for USPS for reading handwriting on envelopes, and also for the Department of Defense and multilingual OCR. So that's so there are use cases here of you being able to detect problems using handwriting analysis, and I'll go through one that's based on screening and one for intervention. Similarly, on the multimodal space, I'll talk about a couple, and then about learning material enrichment. So screening using DDBIC, approximately 15% of people in the US have dyslexia, and that equates to over 30 million adults, according to these sources. Essentially, with written material in the published literature, educators and speech language pathologists have found a number of behavioral indicators that are potentially indicative of various levels of dyslexia, maybe in combination, not necessarily individually. And so here is some writing from children. So vocabulary, like you see, repeated use of and here, idea development and organization. The format of each of these sentences is very similar. And there are like 15 of these, some that are related to writing, some that are related to reading, the R indicators and the W indicators, and some that are indicator of both. And again, this is one of those things where AI can potentially help identify these in a and also develop metrics that are more robust than what is currently being used. So some examples here again of more features here: space planning, margins. AI can help detect these within writing samples, transpositions, inconsistent sizes, etc. These are all samples provided to us by our collaborator at University of Nevada at Reno, Abby Olszewski, who's an SLP. And again, so these are all examples. What do we need to sort of be able to capture those characteristics automatically? Some things are more like pencil grip. You might need to get that from the video. Pressure, if we use an online tablet, and I'll show you an example of a prototype writing pad that like one of our partner industries has supplied to us, which can automatically provide to us some of these things like writing speed and pressure and other characteristics. The other behaviors such as time taken, again, all of this, if it's online, it's very easy. If it's offline, you can't get some of that information. Some things are nonverbal, frustration, evasion, focus. This may be a long-term goal of how do you get technology to read that from faces and other characteristics. But then from handwriting, there's a bunch of things that we can do that involves some structural analysis, like the writing type, like, is there atypical writing, the use of margin, space planning, etc. Some might require handwriting recognition for you to realize that there was an inversion or a transposition. You might also need semantic analysis. You need natural language processing to actually understand that there was a grammar mistake being made, or etc. Then there is, so a combination of these modules is required to get at all of this, and we want to work on that. So here is this prototype tablet. This tablet is very paper-like. It's just a clipboard. It's an experimental prototype. This is, you can drop it. It's not going to break. It's not like writing on an iPad. It feels very much like writing with a pen on paper. And so you can paint any task you want onto this thing. It's a bitmap. And then when you write, you capture the ink traces. And that ink trace, so you can ignore the lines and you'll get only the ink trace. And this gives us a lot of power here. So you know how long the child was writing, like when was the pen down, when was the pen up, how much off the paper was the pen. All of these characteristics can help us even understand how good of an indicator handwriting might be for dyslexia and other SLDs, right? So again, this is the pressure, and you'll get exact measurements of pressure at various time periods where the child was writing, the tilt of the pen. Also, this is the pen trajectory. So this gives you this ability to sort of plot all of these things and be able to threshold and see. The educators might have noticed that, like, that somebody grips something very hard or used a lot of pressure. Here you have metrics that will tell you exactly what those values are. How do you threshold that? How do you get good sort of metrics for identifying this? What are false positives, what are not, etc. So on the intervention side, and again, I'll just sort of rush through this. Structured word inquiry is a thing that some people have proposed to use 4 questions to guide inquiry. What is the meaning of a word? How is the word built? What are the relatives? How are the graphemes functioning in the word, etc. To understand spelling, pronunciations, meanings, to teach and for children to understand these things. And it integrates 4 language modalities: the reading, writing, speaking, and listening. So you have a word matrix like this. And so can you sort of understand? So let's see, like, if I have, yeah, so you can improve decoding, you can improve graphophonemic awareness, you can improve encoding if you use something like this to, so it's for children that are just learning, typical learners, as well as children with speech and language challenges. This is a very good tool to use. So we thought that, like, let's see how technology can be used to help do this, right? Structure it in a scaffold it in some ways. We can use large language models to, based on what a child is working on, generate a word matrix that uses the base word that's familiar to the child, brings in a set of prefixes and suffixes that the child may be familiar with, and see how the child performs, where the child can still, so you're going to paint this onto this pad, the child will write this word sum and the answer, and our algorithm will recognize it and produce metrics. All of this can happen without the SLP being there, and we can layer other kinds of multimodal input here to teach children things, and to, so there's a lot of potential here. This is just this beginning. And again, this is just a screenshot from, so if you write this on that tablet, so on the computer, you'll see like the technology recognizes the different pieces of the writing and is able to recognize that and provide some feedback, and we can layer more things on top of this. But this is just the start. So other novel intervention tools, this one is very interesting from our partners in Stanford. Again, these are not tested, validated. That needs to happen. This is sort of like blue sky ideas that they're trying. And here, this is a virtual mirror. So if you had the child can have their own picture, and then the AI will cause the AI avatar of that child to move their mouth to mirror the speech, and with the appropriate emphasis and the lip movements. And let me just play this briefly. And this is actually a working demo. So this is where...
Why yell or worry over silly items?
So just to set the context here, so you can type text here, and that text is now, so the AI is converting that text to audio, and the audio is being spoken by the avatar on the by this image on the screen, and moving the mouth in appropriate ways. And so obviously this is again still experimental, but this could potentially be something that could be used in demo conversational interactions, integrate into reading storybooks, practicing longer sentences, etc., learn listening skills. So there's a number of applications that this could be used. And I'll just show an example of something being typed here.
Marvel movies are not cinema.
So this is AI generating it, and that's actually AI sort of taking that text and doing all this, the lip movement, etc. So this is something from our lab, where flashcards are an important tool that SLPs use for various intervention approaches. For example, contrastic intervention approach is one approach. This is what like a typical SLP's room looks like. They have all these different boxes full of flashcards, etc. And essentially, they first talk to the child, they determine the extent of the speech sound disorder, decide if it's mild, moderate, or severe, select which intervention method to use. Then if they decide that this minimal pair therapy is what is appropriate, so they need to select two words that differ by a single phoneme where the child has a problem. So if you had pig and big, and the child sort of pronounces both the same, the p cannot distinguish between the, cannot produce the p and the b sounds, then you need to pick a set of flashcards that differ in that one particular syllable, and then you sort of work through the through some exercises with the child. So you need to understand what the place of articulation is, voice, manner, etc. for these two words, and essentially prior to the session the SLP has to select, and this is all of the grunt work that the SLP does behind the scenes before even interacting with the child. They have to select this pair of words, they have to rifle through their card decks, find these cards, have the child, so then go through the intervention with the child, point to the named words, and then have the child name the words in a reversed role, continue working with the child till they attain certain level of correctness, and then progress to other words. And so we thought this was a very good, and so the way we have been working is talking to SLPs, finding something where there is a AI can play a role, right? And here, like AI, currently SLPs cannot create culturally appropriate, relevant, personalized materials on the fly. They have to go to their boxes. These are things that they buy, and they might not have flashcards. So when implementing the speech sound therapy, it takes some time for them to find the appropriate stimulus words. To what can AI do? It can generate custom flashcards based on your target goals. It can be related to the current classroom materials that it knows that the child is working with. It can generate things that are culturally familiar to the child. It can create engaging flashcards that targets a child's interests, and it could be multilingual, right? And so I will skip this. Large language models, you're all familiar with ChatGPT. This is just a little bit of primer on how the training works. One of the things that it uses, one of the early methods that was used by ChatGPT was this next word prediction. And here is an example of just with next word prediction, what can ChatGPT learn to do, or like our LLMs of their ilk. So grammar, right? Like in my free time, I like to, if your choices are run or banana, it knows to prioritize run over banana because it makes more sense. Just based on the training data that it has seen, it's just learning from all of this terabytes of text that it has looked at, and it's understanding grammar in some sense, understanding within quotes. It knows lexical semantics. I went to the zoo to see giraffes, lions, and so if you are looking at between zebras and spoon, it knows to pick zebras. It even somehow learns world knowledge because it sees Denmark and Copenhagen appearing next to each other. So it'll know how to complete the sentence. The capital of Denmark is Copenhagen, when it's sort of looking at choices like Copenhagen and London. So that's just an example of how language models can learn all these really fancy things that ChatGPT does, right? Like, I mean, that amazes everyone. But there are problems, not that there aren't problems. So this is again, which is why, so just next word prediction is not really enough. So you need to do this instruction fine tuning for alignment. And alignment here is alignment to a task. If I'm trying to use this for addressing an intervention, the LLM needs to know what I'm using this for and needs to sort of provide appropriate output for me that meets my needs. And that's one of the things, that's techniques that is used. There are diffusion models, which is you have a text that describes something like an astronaut lounging in a tropical resort in space in vaporware style, and then the AI engine produces this image. So this the diffusion models is one set of models that's used to do this. So all of this we used to do this flashcard generation demo for SLPs. So essentially there is a user prompt. This is what the user will say. I need to generate a pair of words with maximally contrasting phonemes that differ at this initial location. One of the sounds is this. And so then there is some system prompt that you need to do, this prompt engineering, and then you unify this, then you sort of send an image. And these need to be more complex than this. This is just a toy example. And then you use these engines to sort of produce these flashcards. And then you can use them in lots of interesting ways. And I'm going to just switch for a second to show some examples of this live demo, if I can find my browser window. And I know that I'm already running out of time, so I'll just zip through the rest. So this is an example. I hope you all can see my screen. So there are multiple image generation models. You can choose different styles. So I'm using DALL-E 3 now, and I want a children's playbook style with this. So right now you're seeing this was from the SDXL model. So you have rake and cake that differ in this one particular phoneme. Now I want to get a different thing, but in a different style. So DALL-E is generating for me this set of flashcards here for ring and sing. And this has a totally different flavor. A child, this might appeal to a particular child. Something that's like that comic book might appeal to a different child. Or somebody might be more taken by, older kids may be taken by more photorealistic images. So here is a way in which you can experiment with different models and different styles, and you can build a lot of interesting applications on top of this. So going back to my presentation. And I'll probably skip the one other example that I was going to use. So yeah, I'm there, learning material enrichment. So this is for text simplification. So you know that a child, so you have the same material and you're trying to administer a test, but knowing that you have a child in your class that has a different reading level, can you sort of adapt your material to the reading level of the child and do some text simplification? So here, the objective is to develop a system to simplify text while maintaining the content. And this is a orchestrator at a individual app level, intervention level, as opposed to orchestrator at the broader scheme of things. And essentially, we have taken questions from various state standardized tests, extracted word questions, because in the framework that we have, that seems to work best, formatted for easy coding use, and use GPT to sort of generate certain options for us, and also determine what the Lexile level. We have a Lexile prediction model, and we have a website that demonstrates that. I'll quickly show you that, and I'll be getting to the end of my talk. So let me go back to my browser. And in this targeted text simplification, we've addressed two questions. One is where we are taking word questions in math, where the answer is easy to compute. So if you were to simplify text, you know that the answer won't change if, so in this case, we are using LLMs to also help us evaluate our simplification as to whether it captured all of the information that was required to produce the right answer. So you have, this may look simplistic right now. This is one long run-on sentence that says the file 90 megabytes in size downloads at the rate of 5 megabytes per second for its first 60 megabytes, and then 10 megabytes per second thereafter. How long in seconds does it take to download entirely? The simplification here at target Lexile level 700 is a file measuring, and so this is predictions, may not necessarily be right. So we have metrics for whether the Lexile prediction thing is right or wrong. But the simplified text is a file measuring 90 megabytes needs to be downloaded, initially download. So you split it up into shorter sentences and then do that. So the minimally simplified one splits it into even shorter sentences and does that. So similarly with science, we chose multiple choice questions because the answers can be pre-computed. You know what the answer is, and then you so that way you can determine whether your simplification captured all of the right sense. And we do it in two steps here because we also change the choices that are given. This is all from our colleague in Cornell Tech, Sasha Rush. So this is a math problem, a science problem. Dawn brought a chocolate bar for lunch, chocolate melted in her backpack. Dawn wants to perform a scientific investigation to determine the reason, etc. So in the minimally simplified version, it was Dawn's chocolate melted in her backpack. She wants to investigate why, which hypothesis should she use. So that's the simplified version. This is automatically generated. It was not human generated. And so there's still like validation studies you'll need to do. There's like more rigorous studies that you need to do. But this gives you a sense for how technology can be useful, how it can really make a difference, or at least that's what we feel, and we are open to be told otherwise. Obviously, our objective is to listen to everyone and not to assume that we know everything. So this is time for poll 3 and 4, and I'm almost at the end of my talk. Kali? So 3 just asks, based on the discussion today, which of these tools piqued your interest, right? What do you which do you think would be very useful? Like, is it the dynamic flashcard creation, the content simplification, or the virtual mirrors, or this handwriting-based detection of things? So we're just curious to know, since you're in the field, what would you think? And we would definitely share this with our funding agencies as well. So yeah, I'll stop this at this time. It's a reasonable set of results. Poll 4, like, we'll just pop this up. It's basically open-ended, and you can either answer here. That may sort of delay us. You can just post it into the chat window, and we will. So Carly, do you want to just bring up the poll 4? I'll just read out the question, and people can type the answers in chat, and we'll capture the chat.
Yes, absolutely. It's having some trouble launching, but the question is, what are some other therapies that you know of that could benefit from these AI-based tools? So I will go ahead and throw that in the chat as well.
Yeah, and
So you can
that was
respond.
not meant to be these AI-based tools. I sort of mistyped it, but it was any where you think like, I mean, what are the screening tests that you are aware of, or interventions that you are aware of where you think AI can help, and that would help us sort of also prioritize what we choose and which ones are likely to be more representative of a class of interventions, so that whatever we develop can be more impactful and can help address a bunch of challenges. So that will be really useful to us. So in terms of ways of engagement with us, we want to hear from all of you. We want to get input from as many people as possible. What can the AI Institute do? We've been engaging in this with school districts, with other SLP organizations, with others, but we would like to do it with as many people as possible. So training, we can provide training on AI for educators, as in educating people on AI technologies that are out there, that they're aware of, that children, students use day to day, they themselves use, but something where we can give them more nuanced understanding of how those AI technologies work. We are also interested in talking to SLPs and training them about one, reassuring them that our intent is not to take away their jobs, as it is they're overworked, and it would be sort of adding insult to injury to sort of do something that would be existentially problematic for them. So we want to educate them as to how, like, I mean, this AI technologies will be useful for them, and also get their input, feedback, and also help build better tools, or even know of what else we can help it use for AI. The same question that we asked all of you, we can sort of engage with more and more SLPs. STEM outreach activities for students, again, interesting them in robotics, interesting them in all these AI-based technologies and STEM related topics. Outreach to advocacy groups parents may not know about, or maybe also concerned about what AI technologies would mean to their wards. So we could help in understanding their fears and also communicating how we are doing and get some feedback from them. Partnering with school districts for validation studies. This will probably be a little down the line, but we do intend to do that. And we have a lot of school districts locally that have volunteer to partner with us. We just have to figure out the engagement mechanism. We are also working with not just SLPs for co-design of the technologies and feedback, but with all stakeholders, including students, parents, caregivers, etc. So with that, poll 5 is the poll 1 repeated again as to what you think of AI, and are you now excited, or are you still neutral about it? Do you want to pull that up, Carly? If you can, if you can't, that's okay.
It looks like another poll is launched right now, which is what I'm seeing on my end. So I apologize for that.
Okay. Yeah. Anyway, so
in any case,
go back to my slides, and I just wanted to leave everyone with my here is the poll. It did show up now. Yeah. Can you guys see the poll? Yeah, it seems like from early results, at least, things seem to have sort of moved into the still, like, I mean, in the excited and intrigued stage. And since we are about 75%, I'll end the poll and I'll stop sharing that. And I'll leave you with my contact info. I'm the managing director of the Institute. My email address is setlur@buffalo.edu. You can also reach us at info@aiforexceptionaled.org. And I'd be happy to take questions.
Ranga, I want to share a question that popped up in the chat earlier. So in the model you demonstrated where a student views an AI saying the baby is sleeping, and then what they're meant to model is the kitty is sleeping. The first question was, what if the child said something along the lines of the cat is laying? Would the AI be able to detect that the sentiment was the same?
Yes, natural language processing, like, I mean, you can sort of the different presentations of the same sentence. There are techniques for us to sort of be able to do that at various levels of success. Obviously, those that have interacted with ChatGPT are sort of aware of how the large language models can sort of understand your intent and can produce all these variations that mean the same thing. And even if you ask the questions in different ways, it can sort of produce answers that are responsive. So the same kind of technology can be used to understand what the child is speaking. Again, here the basic speech technology is itself needs to be improved because children's speech is not as understood because there aren't as many data sets there. But in principle, the language related question, if it is, can I understand two sentences that mean the same thing? Yes, AI can do that. Yeah.
Excellent. And then the follow-up question that's a little more complex. What are the ways that AI in such a situation could be biased regarding the use of standardized language versus an evolving language that may be used by children who are speaking a second language? And how can we protect against any bias for example, English language learners?
Yeah, that is a very important and very interesting question because we are very aware of that. Again, as I said, like with some of these, so those are all things that are in our focus. Not only that, like, I mean, even with respect to language, and so that's why we have all these board members from across the spectrum. One of the things that the ASHA board member pointed out to us was the distinction, the danger, which sort of is a reality right now in schools of African American English sometimes being sort of considered non-grammatical, and sort of there being biases due to that, where there are cultural differences in how language is spoken, and being aware of that and being making sure that the technology is not biased towards one or the other. So we are aware of it. I'm just giving a glib short answer, but it's because it's a hard problem to solve, but it is something that definitely needs to be kept in mind and is definitely within the focus of our institute and our researchers and before we bring any technology to the field, we would test it against all these biases and make sure that the technology is able to perform well on these.
Thank you. I'm seeing a related question in the chat, so I'll read that out. In my experience to date, AI speech recognition technology does very poorly when the speaker has any sort of accent or speech impediment. Have you experienced this, or have you experienced growth in that area?
Yes, that is a very well-known problem. As I said, like there's not as much money to be made in sort of recognizing children's speech. So all of the commercial tech companies are focusing on ASR. They want to sell their Alexas and their Siri-powered devices, and they are the people that will use those devices to purchase something somewhere and like come in and sort of feed into the economic model that they have. So children's speech is like one of those that is sort of ignored. Some of the tech companies on the social technology development divisions are focusing on things for adults that have speech impediments, and Google has a project called Project Relate. They don't want to address children's problems because they're afraid of liability, but they have been working on adult speech and producing tools that can help people with severe issues in speech and building technologies that can help translate their speech to, for example, if they go to translate their speech to a barista in a Starbucks, because humans cannot understand that speech, but AI can help translate what they're saying to the and get their needs met. So people have been working on it, and even so I shouldn't be just complaining about the tech companies. So some of them do have a lot of effort going on in AI for social good causes. But again, they're not focused on children, and children are especially sensitive, even for those big companies, because of potential liability concerns. We are also very watchful and careful, but we feel that there is a really pressing need, and we do need to develop these technologies to help these children get their, at least from an academic perspective, improve their prospects.
Thank you. And one more question that popped up in the chat in regards to speech recognition. In terms of speech recognition, can high-pitched or emphasized words or phrases have different weights compared to monotone or normally tuned words and phrases?
Yes, I mean, intrinsically, whether it is with any of these AI large technologies, whether it is vision technologies or whether it is the audio processing technologies, obviously the user base is very diverse, and these models are trained to cover this entire spectrum, even the long-tailed the characteristics that are not very commonly seen. They do want to address all of those. So again, biases can be there with respect to this. You've seen face recognition being the post. We work in biometrics as well in our lab. Face recognition has got a bad rap because the initial models were trained on data that did not have too much diversity and did not perform poorly on certain faces of certain skin color. So it's so obviously, like, I mean, there are issues. You need to sort of address all of this, and people are very aware of it now. And so there is more and more emphasis in making sure that there is enough training data across a very diverse set of users, and then developing the technologies that hopefully do not discriminate against sections of the population. Any other questions? Comments, suggestions? Anything is welcome. If not, thank you all for attending. I hope this was of value to you, and we look forward to hearing from you, engaging with you if you feel the need. Thanks again.
Thanks all for your time. If you haven't gotten the chance to fill out that Google form, we really would appreciate getting your feedback. It'll help inform future sessions and help us as we build out our research portfolio, working with the community around us. So thanks all. I dropped it in the chat one more time if you have 5 minutes.
Thank you.
All right.
Thank you both.
You're welcome.
Ranga, do you want to stand for just a minute? I'll stop the